Hi, welcome to the Shiko Math Lab Fun Probability Problem Solving sections. So today, the problem we're going to solve today will kind of related to the multinomial distributions here. So let's take a look at today's problem. So today's problem is let x be the number of ones and y is the number of the sixes occurred in when you roll a failed die n times here, all right? So I have the random variable x and y. Now I want to compute the covariances of x and y's here. All right, so let's go to our whiteboard and start to solving these problems here. Okay, so for the x is the number of ones, occurred in n rows, and the y is the number of the six occurred in the nth rows here. So we know the probability of xy's here is a multinomial distributions, right? So it will be what? It will be the n, and then I have x is 1, y is 6, and what is remaining? The remaining is n minus x minus y here. Then we know to get a 1 is 1 over 6 to the x power. Then this is 1 over 6 to the y power, right? Then the remaining, not 1 and not 6, will be 4 over 6 to the n minus x minus y. So here, x can be from 0, 1, 2, to the nth row, and the y could be the 0, 1, 2, to the nth rows here. Okay, so the problem asks us to find the covariance of xy's here. So we know the covariance of the xy. In order to find the covariances here, we need to find the expected value of x times y minus the expected value of x times the expected value of the y's here. So the first is here, let's try to find the expected value of x here. All right, so if in one of the previous video, we have talked about the marginal distribution of the multinomial, and we know the marginal distribution of x is a binomial, right? So it's the binomial with n and p is equal to 1/6. So we can use that fact and directly say, okay, because of the marginal of x is a binomial, so I know the expected value of x could be what? N times p, right? So it's n over 6. We can get it from that, or let's just from the joint distributions definition point. Let's see if we can get this or not. So in here, let's say, okay, so this is the expected values, right? Okay, so the expected values here will just be from the joint distribution point. I can say I'm going to have y equal to 0 to n, and then here this is x equal from 0 to n here. Then I have times x, right? Then the x in here and the x, y, and n minus x minus y. And then 1 over 6 to the x and 1 over 6 to the y and 4 over 6 to the n minus x minus y here. Okay, so I'm going to manipulate this, this part. Okay, so I'm going to manipulate this part here. All right, so let's see how do we do that. So here, this will be the x here, right, times, and then this will be the n factorial, then this will be the x factorial, y factorial, then this is n minus x minus y factorial, and then this is 1 over 6 to the x, this is 1 over 6 to the y. then this is 4 over 6, the n minus x minus y here. And then here, I know the x and the x factorial, I can kind of simplify that. So this will be n minus, so x factorial, you can simplify to the x minus 1 factorials, right? So you can cancel the x. So this will be the x minus 1 factorial, and this is the y factorial. And then this one's okay, so this one's here will be the n minus x minus y factorial. And then for the top, the n factorial, I can rewrite this as n times n minus 1 factorials here. Okay, later you will see why I want to change it to here. This is 1 over 6x, this is 1 over 6y, and this is 4 over 6 and minus x minus y. Okay, so now take a look here. So if I take the n outside here, right? So the n's, if I let the n come here, all right, so then this is n minus 1 factorial. Then this is x minus 1 factorial, y factorial. Okay, so take a look at this ones here, the n minus x minus y. I can rewrite this one to be the n minus 1 minus x minus 1 minus y factorials, right? So that's why I can rewrite this one to the n minus 1 minus x minus 1 minus y factorial. Okay, so then in here, this is 1 over 6. See here, the negative 1 minus x, and then negative positive. So it's canceled. So I did not change anything. So it's 1 over 6 the x, 1 over 6 the y. Then this is 4 over 6 and minus x minus y here. Okay, so now in here, take a look at n minus 1 is here, and x minus 1, right? X minus 1 is here, and then this is y is here. Okay, so now if I put, okay, so continue here. So this one will be the summation. Okay, so the summation y equal to 0 to the n, and the summation now in here, because I drop off the x, so x is start 1 to n. All right, so the then in here, okay, so the now in here, this number says n, so I can take this n outside, right? Okay, so I can take this n outside, let's say here, I take the n outside because n has nothing to do with the summation x or y. So x equal to 1 to y equal to 0 to the nth here. Okay, so now in here, this one's here, this is n minus 1 factorial. Then here, this is x minus 1 factorial. This is y what? This is y factorials, right? And then in here, this term here, take a look at this term. All right, so this term here, 1 over 6 to the x, I can change it to the 1 over 6, the x minus 1 times 1 over 6. So I can move this 1 over 6 to the front here. Okay, so now in here I have 1 over 6 to the what? X minus 1. Then this is 1 over 6. This is the y. Then here, oh, sorry, I need to be careful. I did not write it right here. So this one's here. This is n minus 1. minus x minus 1 minus y to the factorial. So then here I have 1 over 6 to the x minus 1, then 1 over 6 to the y. Then here this is 4 over 6 and minus 1 minus x minus 1 minus y here, right? Okay, so just like we highlight here, so these things here, right? So these things, so what is this? This is the sum of multinomial distributions, right? So the whole things here will be sum up to what? Sum up to where? Sum up to ones, right? Because when you add all the, the probability for all the numbers in the domain will sum up to 1. So this is a multinomial distribution with n minus 1. Then the x is x minus 1 and the y's here. All right. Okay, so now let's write in here. So let's write this is n over 6 here. Okay, so it's kind of the match what the original we think, because of this is the marginal distribution is a binomial, so the EX is equal to the n over 6, so it's a match. So we can do the same things, right? So we can do the same thing for what? For the expected value of the y, because the y is exactly the same like the x's here. So what is the expected value of the y's here is n over 6 here. Okay, so now let's go to the next page. Let's take a look at the EXY. Okay, so for the EXY will be the same things. Here you use the definition of the marginal distribution. So you will have y equal to 0 to the n, x equal to the 0 to the n's here, right? So then you times the xy. Then here, this is n factorial, x factorial, y factorial. Then this is n minus x minus y factorial is 1 over x, 1 over 6, 1 over 6 to the y, and 4 over 6 to the n minus x minus y. So we do the same trick, same way we manipulate our the terms here. So here you see you got 1x, you got x factorial, and you got y, you got y factorial, all right? So let's try to rewrite these terms here. So this will be, so this is x minus 1 factorial, and this one here is y minus 1 factorial. So the n factorial, let's change to the n to the n minus 1, and n minus 2 factorial here. So let's change the last term, n minus x minus y. So these terms here, I can change to the n minus 2 minus x minus 1 minus x y minus 1, right? So the factorial. So this is the term I can change to n minus xy. I can change it to the n minus 2 minus x minus 1 minus y minus 1. So that's why I want to have n minus 2 here. Okay, all right, so now the same ways here. Okay, so the same things here. So the 1 over 6, I can change it to the 1 over 6 to the x minus 1 times 1 over 6. And then the 1 over 6, y minus 1 times 1 over 6. Then I have 4 over 6 and n minus 2 minus x minus 1 minus x minus 2 minus y minus 1, right? Okay, so this is a minus y minus 1. All right, so now in here, let's put everything is not related to the xy to the front. This one, and the what? This one's here, right? Okay, so now let's put everything. So this will be n times n minus 1 and 6, right? Times 6 is 1/36. Now I can rewrite this ones here because it started x minus 1. So I said x1 to n, y equal to 1 to n. So in here I have n minus 2 factorial. All right, so I have n minus 2 factorial. So this is x minus 1 factorial, y minus 1 factorial. And then this is m minus 2 minus x minus 1 minus y minus 1. Okay. Okay. So now in here, this is the factorials here, right? So then I have a 1/6 x minus 1, 1/6 y minus 1, and 4/6 n minus 2 minus x1, this y minus 1 here. Okay, so now we know all this is the sum up to what? The sum up to what, right? So now I know my EXY will just be n to the n minus 1, 36. Okay, so now my covariance of XY will just be the n to the n minus 1, 36 minus n to the 6 times n to the 6. So it will be 36 n squared minus n, then minus n squares, right? So what? So my final, the answers here. This will be negative n to the 36, and this will be my, this will be my covariances here. Okay, and that's it. So this one here is like very interesting. Basically, you can manipulate and try to match it, become a joint PDF form or the joint mass distribution forms here for discrete random variable, and then use that fact to find the EXY, and also you'll be able to find the covariance of XYs here. All right, so nice talk to you, and let's see what the type of the problem we're going to work on for the other day. Okay, talk to you later. Enjoy. Bye.